To understand the energy and hydraulic grade line, you need the Bernoulli's equation expressed in terms of height. Each term in this equation has a dimension of length, later which is used for visualizing the energy grade lines. Hydraulic grade line can be visualized with a piezometer tube. It measures static pressure by calculating the liquid column height through the center of pipe. If you tap piezometer into several locations and draw the curve through the liquid level, then hydraulic grade line is obtained. Notice, hydraulic grade line just represents the sum of static pressure and the elevation heads. Elevation head depends upon the datum we choose. Now we choose in the center of the pipe, but we can choose anywhere. Now what? If the same pipe is inclined? In this case, change in elevation head will affect the hydraulic grade line. With change in elevation head, results increase in hydraulic grade line. You can imagine hydraulic grade line as potential energy, which is related with Earth's gravity and datum. Energy grade line is the sum of potential and kinetic energy, so it's the total energy of a fluid. In order to visualize kinetic energy, which is related with the velocity of water, we need a pitot tube. Extra height the water column travel is related with the velocity of water, and if you draw the curve, you will get the total energy, also called the energy grade line. The distance between EGL and HGL is the dynamic or velocity head. You can also imagine it as kinetic energy. Okay, now, consider a large tank or reservoir is filled with water. Let us visualize the EGL and HGL of this flowing water by fitting piezometer at different location and drawing the curve. The black and blue line is also the HGL line. Blue line denotes pressure and black line denotes elevation head, and sum of these two lines is HGL. And the pink one is the velocity head. At point 0, that is, at the liquid surface, EGL and HGL coincide with the liquid surface, since there is no flow or velocity there. In an idealized Bernoulli type flow, EGL is horizontal, and its height is always constant. HGL decreases rapidly as the liquid accelerates into the pipe. The difference between EGL and HGL is velocity head. HGL is the sum of pressure and elevation head. Velocity of water increases at point 2, so HGL decreases, and velocity head increases. Then again along the length of pipe, the HGL increases, as the velocity decreases. You can imagine HGL as the potential energy, which is greater than kinetic energy. And the sum of potential and kinetic energy is the total energy, or EGL. And finally, HGL decays to the liquid surface at the outlet, since the pressure there is atmospheric, as the pressure head is 0. However, EGL is still higher than HGL by the amount of velocity head. Remember, in real life there is always presence of friction and heat, which decreases the total energy of fluid, so EGL will never be horizontal. Please subscribe for more fluid mechanics.